right, I'll just jump right into it. Hi everybody. My name is Darron Jurajda. I'm the Business Operations Director at Brewer Science, and a little bit of background about myself. Born and raised in Texas. I started off thinking I was going to go into the chemical manufacturing, like Dow Chemical or DuPont or something. Even did some interns and co-ops at some of those big factories on the Gulf Coast. But at the same time, in university, I did a lot of undergraduate work in the semiconductor industry. When it came time to get a job, uh, yeah, let me restate that. So when I was looking for a job, there's a lot of semiconductor industry in Texas and really throughout the world, in a lot of places that you really, really wouldn't expect there to be semiconductor industry. So that kind of got me on the career path. And then soon after working my first job in the semiconductor industry, I found out about Brewer Science. And that was back in 2002 or 2001, maybe. Got a job at Brewer Science and never looked back. So to me, one of the interesting things about the semiconductor industry when it comes to manufacturing compared to what most people think of traditional manufacturing is it can really happen almost anywhere. And the supply chain for the semiconductor is really a global supply chain. I mean, there are suppliers everywhere in the world. There's suppliers in Rolla, Missouri, like Brewer Science. There's suppliers in uh, towns you wouldn't think of in Montana that are supplying the semiconductor industry. You know, Anywhere from big cities, heavy industrial places in China to rural places in Europe, in the United States. And the reason that is the semiconductor industry really values high quality and high quality supply chains, high quality suppliers. So it's not necessarily about the scale or logistics, are you close to a port or something like that? It's really about the quality of your materials. And that's kind of where Brewer Science, fits in. They've had a value proposition for our materials, and I'll get into what that value proposition is from the start. That's what the company was founded on. So if I go back, rewind the clock to when Brewer Science was originally founded, one of the features of the semiconductor industry is it's very, very expensive from an equipment standpoint to manufacture semiconductors. So you have to make sure when you buy the equipment that you're using it to its full potential to get the most out of it. And that's where Brewer Science comes in. Our products allow these semiconductor companies to use that really expensive equipment that they've bought to its full potential, use it to its maximum life of the equipment, get them, most wafers through, be able to produce the highest quality semiconductor products at the highest technology. And that's really the big benefit there. We're allowing these companies to produce the types of semiconductor chips that they normally couldn't if they didn't use our products. And that's kind of it in a nutshell. That's where we come in. And it's just amazing that you can do that from anywhere in the world. So, we have our factories in Missouri and make all the products at the factories in Missouri and ship those to almost every single continent that are used in these fabs all around the world, so that these companies can make the chips that go into your smartphone or go into automotive or you know anything you can think of that has semiconductors. And you know one of the other interesting things about the semiconductor industry is that our products are getting into more and more consumer devices or consumer electronics every year. People, you hear about it now, semiconductors in content in cars, but even things like trains. You would be surprised how many semiconductors are in trains. They said there's a half square meter of chips in each locomotive. If you put all those chips together, that's a
Wow.
lot. That is a lot of semiconductors. You think of, chips are tiny. You had so many put together that it would make a half square meter for each locomotive. So, things like, these electric locomotives, electric cars, any kind of electric engine, every device. And, brewer science is one of those pieces of the puzzle that allows all of that to happen. And to bring this back to, well, how does this fit with Missouri? Um, the reason that we're able to do this in Missouri is kind of what I mentioned before, is what semiconductor companies and the semiconductor industry values is they value the high quality, the value that you can bring to them. And if you can provide that value, it doesn't matter where you're located. You can be located in central Missouri. You could be located in Springfield, or you could be located in Hsinchu, Taiwan. But as long as you're providing the value, the location doesn't matter, and that's really um, it's really one of the beautiful things about the semiconductor industry, because then you can live in a nice location. You don't have to, if you're working in the semiconductor industry, you don't have to live in an industrial science park. That was one of the things I was facing when I was choosing my job coming out of university. If I was going to work in a traditional chemical engineering role, my choices were things like, Freeport, Texas, on the Gulf Coast, where the largest structures are petroleum refineries, or Midland, Michigan, where half of the city is a Superfund site for the EPA,
Mhm.
places like that. But you go into the semiconductor industry, you can work in places like Raleigh, you can work in places like Springfield, you can work in places like Austin, Texas. Um, so yeah, that's in a nutshell.
Whenever you were going to college, or when did you know what career you wanted? How did you just,
Uh,
as you were growing up, when did you have that aha moment? This is what I want to be. Tell us about that.
mhm. Okay, so um, I might be a little unique because I knew from pretty early on I wanted to do something with sciences. Um, and in high school, or in middle school, I thought I'd want to be a biologist because I really enjoyed learning about animals and biology and ecosystems. As I got into high school, I found out, well, biologists don't really make a lot of money from a career standpoint, even if you love it. And so I had decided I wanted to do, but I still liked chemistry. Chemistry was one of my favorite classes. So I thought, well, if I switch over to chemical engineering, and I think by the time I was a sophomore in high school, I had decided I wanted to do chemical engineering, and it really, yeah, and that just kind of stuck ever since then. But I think what really helped me is I had a really good chemistry teacher in high school. She had a PhD in chemistry, and in the AP chemistry class that I took as a senior, they even taught us organic chemistry, which at the time was very unusual for high school. But I'm finding out now it's pretty normal now to teach. And then also advanced physics classes as well that I took in high school. Just kind of sealed that for me that, yeah, that's probably what I would want to do. And I started off college wanting to get a chemical engineering degree, and that's what I ended up with. Although, how I split from going to like working in a petroleum factory to the semiconductor industry, that actually happened in college for me. So I did some undergraduate research with with a group that was doing some research in the semiconductor industry, photoresist and things. And I had the option to not do the research as a engineering student, but as an organics chemistry student. And I really enjoyed organic chemistry, even though I was doing the engineering side of things. So I did all of my undergraduate research actually as an organic chemist, working in a lab, similar to what we do at Brewer Science, working in a lab, making formulations, sending them to engineers to test, and getting the results and doing tweaks. I did that for 2 years at university, which kind of and then when I started working in the semiconductor industry, when the position became available at Brewer Science, and I saw it and I thought, oh, this kind of ticks all the boxes for me. I had already worked as a lithography engineer in a fab, so that's somebody who uses our materials. I've done organic chemistry research in a research type setting, which is what we do a lot of. That checks it as well. And I also spent 2 years co-oping with Dow Chemical in a Freeport, Texas chemical facility. So I understand the manufacturing side. That checked that box too. So it was like check, check, check. Yeah, Brewer Science is a really good fit for me. And I gotta say, I still feel that way as well. Um, it's been really great working at Brewer Science. It's still very challenging, but it still allows me to, flex my technical muscles, but also learn new skills as well, like all of the business development or sales skills that I didn't have that I have now that I'm still learning. And I can see moving forward, there's still tons to learn. So that's kind of how that evolution went from middle school all the way to now.
Well, I think one of the things is, I think a lot of times there's a perception that manufacturing is, if you end up with in manufacturing, it's going to be dead end, that you'll be stuck on an assembly line somewhere, and that maybe you won't have a lot of options for career growth. You've seen our manufacturing facility, and part of this film series, we're doing we've filmed a tour of our site, our Vichy location. What do you think about manufacturing today and the future of manufacturing?
Oh, yeah. So from a manufacturing perspective, there is so potential for things to improve. So one of the hallmarks also of the industry we work in is continuous improvement. So I also participate in one of our manufacturing work teams, and we are constantly trying to find ways to either make small improvements here, make the products better, make the way we make them better. Um, and there's a lot of room to keep growing and keep learning on the manufacturing side of things. So I definitely would disagree that that's that's a dead end and there's no room for growth. I mean, if you want it to be, sure, you can say I'm just sticking with this and that's it. But at Brewer Science, that's not how we practice it. We practice it with like how can we make this a little bit better? How can we make it squeeze that much more potential out of it. And that's why they call it continuous improvement process. It's never going to stop. There's always going to be more growth, more ways you can learn, new skills that you can learn that can help you. So
Very true, very true. And I do see that we have people in manufacturing. Manufacturing requires some training. It's not like just anyone can walk in and figure it out. But I do see a lot of people who are frontline manufacturing trying different aspects of manufacturing. Maybe they move shipping and receiving, or they go from bottling into another area of the company. But at the end of the day, every position at Brewer Science makes sure that we are looking for ways we can improve, and how can we make the customers, give them something that they're going to be pleased with, and what's their needs. We're looking to the future. What does the future look like for our customers? So there is a lot of different skills that are all needed to make manufacturing relevant to today's world and
yeah.
tomorrow's world as well.
No, that's yeah, that's really true. And actually, just talking about it now, it's making me think about, not just the manufacturing of the processing we do at Brewer Science, but the whole going back to our supply chain management. So how are we getting all of our materials in? Um, there's been huge efforts in the last 2 years to make improvements to that whole process. And so all of those people who are working in purchasing or they're working in supplier development that aren't actually physically making the materials, they're still key into being able to allow us to make those improvements. And then even when you manufacture and then things going out the door, the shipping receiving side, the logistics side, there's constant improvements having to be made there. Just trying to figure out the best way. Um, you would think, well, a box is just a box, but it's not. If the box is holding, this product that's very valuable, we're finding ways to, get these materials into these boxes and get these boxes certified, or innovative ways to get materials in a customer's hand in an efficient manner. That's constant as well. So like none of those areas of the whole supply chain or end-to-end product, end-to-end life of the product within brewer science is static. It's not static all the way from getting it raw materials from our suppliers to getting it out the door. And so all of those groups are always having to learn and push the boundaries of what's possible in their area.
Now, you're in an area where many times you will be bringing a customer or a potential customer into brewer science, and then it opens up a window for you to hear, to see us through the customer's perspective. That puts some extra pressure on you to try to explain what they're seeing, but also how do we use that information? When a customer comes to us, how do we see that adding value to brewer science and to our products?
So when a customer is coming to us, the value there is just finding out what's important to the customer. So every customer might have a different need, and not just from a technical product need, but some other need. It could just be a supply chain need, or a quality need, or you know, or a service need. And so, the value is hearing what that is and being able to prioritize the projects that we're working on, because we always have a huge list of things we want to do. That list is so long we can't do all of them. So how do you decide how you prioritize them? And one of those is finding out, well, what's going to give the customer the value that they want the quickest. Is it making some technical improvement to the material, or is it providing the material in a different bottle type? Like,
Yeah.
depending on the customer, those are both equally valid. So having that customer feedback is valuable for us deciding. And then on the other side of it as well, having the customers come in and see brewer science is valuable for them, because if they can see, here's all of the systems, here's all the qualities, things that we have that are there to protect you, it puts that customer mind at ease and basically helps them prioritize, okay, which suppliers do I need to work on to make some improvements? And 9 times out of 10, it's not us. We're pulling our weight. We've won awards from several other quality awards from several other customers as well. And for them coming to see us helps them go, okay, I don't have to put resources into brewer science because I know they're gonna manufacture things to a high quality and take care of us. I have to worry about these other suppliers. So it goes both ways when they come and see us, and we have to explain, what we're doing and why it's important.
I'm going to ask you a couple more questions, but the big one
Yeah.
that I was thinking about is, sometimes when a student is hesitant to become an intern or do a co-op program, sounds like you did some intern work. How was that helpful to you, being an intern?
So, being an intern or co-op, it's really helpful because you have a concept of what your job is going to be just based off what you learned, but it never matches up with reality, to be honest. So, once you get into a work environment and you really start to understand what's important, I'll give one example. We learned all of these things in my chemical engineering classes, like reactor designs and reaction kinetics and unit operations and all these things. But the class that I used the most was my statistics class. And if you would have asked me before I worked in the semiconductor industry or got co-ops, like, hey, which class you think is going to be the most important, I would not have guessed it was my statistics class, but it is. So having those internships really helps you kind of zone in on, okay, what have I learned already that's going to be, really applicable, so I know what to pay attention to when I finish up the rest of my studies. That's, to me, is the invaluable piece. And then especially if you're having, you know, and just learning what it's like to work in that industry as an engineer, um, rather than just having the concept of what you think it might be like. All right, but yeah, to kind of answer the question of like what else, to consider. I guess, one thing that we always talk about when we're talking about workforce development in the semiconductor industry is, we really want people to be aware that there's a lot more when it comes to high tech jobs in the United States beyond, Apple, Google, Amazon, Tesla. You know, that those are the companies that get a lot of press, and people think about when you think about high technology. But the reality is the semiconductor industry is strategically important for the United States. It is, after I think oil and aerospace, the number three biggest import or export, the number three biggest export of the United States, which is huge, and people kind of take it for granted. But we have a trade surplus with China in semiconductors. One of the few industries where we actually sell them more than we purchase from them. And I think that gets lost. A lot of people don't really realize that we are a world leader in that area. Um, and yeah, that's something I would probably stress with people. Like, it's a very important industry. It's very important to our country. And we're actually really good at it.
Yeah,
so so
very
that right there should tell you a lot.